Hello, everyone, and welcome. Welcome to IBM and SiB Solutions Enable Flawless Logistics with IBM Code Engine event, Containers Made Simple. So thank you all for joining. Go ahead and share in the chat where you are joining from today. I'm currently joining from Detroit. We have our guests at SiB Solutions that are joining today. From Sweden. Looks like we have some people from New Jersey, Tunisia, so lots of time zones going on here. There we go. So to get started, all of the slides will be available to you. If you scroll to the top of the chat, I have all the links there as well. So this is the link to the slides. The session is being recorded, so you can access the live stream recording at the same link you joined with on Crowdcast. If you're watching from one of our other IBM developer social channels, this is where the live stream recording will live after, if you'd like to refer back to it later. If you're interested in getting hands-on with Code Engine and trying out some of our services, you can do that with the IBM Cloud sign-up link. Doug will be hanging out in the chat to answer any questions you have as we go along. So don't hesitate to post any questions you have in the chat as we go. And we'll also have time for Q&A at the end as well. This is the IBM Code Engine repository. Lots of sample apps, some great tutorials. We're going to be adding some more cool stuff to that very soon, just in time for Hacktoberfest. So stay tuned. Make sure you star the repos so you can stay up to date with as we add things. So feel free to share in the chat. I'm going to go first, kind of introduce myself so you can get to know me a little better. I'm going to pass things over to our guests at SiB Solutions so they can introduce themselves. I'm going to do a brief intro to some of the technology and things we're going to be talking about today. And then we're going to get more into depth with SiB Solutions, who they are, what they do, how they architect their solution, how they're utilizing IBM technologies and Code Engine to enable flawless logistics through their services. So my name is Jenna. My pronouns are she, her. I'm a cloud developer advocate with IBM. I'm from Detroit and currently joining from Detroit. Sometimes I'm in New York, sometimes I'm in Austin, just kind of depends what's going on. Something I love are my dogs, which you might have heard them being naughty at the beginning, but they're put away now, so they'll be nice and quiet. And a quirk about me, I have a weird obsession with tuna melts and tuna salad sandwiches. So if you have any recommendations, feel free to send them to me on LinkedIn. I'm always looking to try new places. So I'd like to pass things over so you can get introduced with our special guest today, who's going to be giving you a really great technical deep dive and overview in a little bit.
Yeah, hi everyone. My name is Sverre Valgeir, and I am joining from Trelleborg in Sweden, the southernmost tip of Sweden. And some quirk, I don't know, that would be that I'm a nerd, really a lot in every sense of the word. So I have to know every programming language or any technology there is. That could be a quirk, I guess. That would be that. Looking forward to talk more to you.
Thank you so much. Yes, the more I get very excited by any new technology, any new coding languages as well. So as long as I get a sample app cranked out, I'm happy. Okay, so just a sec here. Okay. So as always, I have some great badges here that I recommend that are really great, giving you a really great foundational background into all things cloud application development, Docker, cloud native. So feel free to check those out in the slide deck as well. So as I mentioned, this is our agenda for today. So we're going to talk about containers. We're going to talk about container images, registries, what is serverless, and then we're going to really go into depth about what is Code Engine, what are the different things that we can do with Code Engine, what are the features and the pros to deploying apps to a serverless platform as a service that is Code Engine. And then we're going to pass things over to SiB Solutions, and they're going to give you a really great talk today. Here we go. So we're going to just start with this, and I just have, if you haven't already, I have a poll question here. So feel free to, at the bottom of your screen, you'll see polls there. You should see them pop up. Feel free to share what languages you're using mostly on a day-to-day basis, and feel free to share how much you know about containers. So a container, as we can see here, a container is just a standard unit of software. It packages up all the code and all of its dependencies so the application can run quickly and reliably from one computing environment and one operating system to another. It's available for Linux and Windows-based applications, and containerized software will always run the same regardless of the infrastructure that you're running it on. What's really great is that containers isolate software from its environment to ensure that it works uniformly despite any differences, for instance, between development and staging. So what is a container image, right? So we talk about containers, and when we talk about containers, we talk about container images. So a container image is a lightweight standalone executable package of software that includes everything needed to run the application, the code, the runtime, the system tools, system libraries, and settings. And you might be saying, well, you just said that. That's the exact same thing that you just said for a container. So the main takeaway here is that container images that you can see here become containers at runtime. And for instance, in the case of Docker containers, those, for instance, if you're using Registry like Docker Hub or Red Hat's Quay or IBM's Container Registry, those container images become containers when they run on Code Engine or any other Kubernetes, OpenShift, right? So today we're going to be focusing on Code Engine, but anytime containers are at runtime, they're going to become containers. So you may have heard me mention Quay and Docker Hub and Container Registry. So basically, Container Registry is a repository where you're storing your container images. Public and private repositories are available, and public registries are great for individuals or small teams, and private registries are a great way to incorporate security and privacy into enterprise container image storage. So as I mentioned, IBM has a container registry as well. It's called IBM Container Registry. And then serverless. So when we're talking about serverless, so Code Engine is that we're going to get into is our serverless platform as a service. So as you can see here, our serverless, we have a serverless runtime that's running on top of our host operating system. So as you can see here, difference between containers and serverless. They're both running on their host operating system, regardless of what operating system you're using. And the main difference is we have a container engine that we're running our containers on. And for Code Engine, for instance, we're running our containers on top of our serverless platform. So let's get in and start talking about Code Engine. So what is Code Engine? What can it do for you? So Code Engine is a fully managed serverless platform that runs your containerized workloads, including web applications, microservices, event-driven functions, and batch jobs. Code Engine even builds container images for you from source code with its source to image feature. So Code Engine can create contained images from source code. You can also deploy from container images from different public and private registries as well. It can access source code in repositories. You can push images to registries. Code Engine is integrated into IBM Cloud and all of the IBM Cloud services. It handles and hides all cluster provisioning, configuring, scaling, and managing servers. A really great feature that we cover a lot in our 101 and 201 workshops are Code Engine's auto scale feature, which auto scales workloads up and down, even to 0, when no requests are active. So if you're not getting traffic to your application, you're not paying to provision services that aren't being used. And it's built on open source Kubernetes, Knative, Istio, and Tekton, which keeps the applications and jobs really portable. Okay. So last part here, when we're working with Code Engine, we have two ways of deploying to Code Engine. We have Code Engine applications and we have batch jobs. So applications are basically just workloads that typically respond to incoming messages like API calls, web page requests, events, or any other HTTP request. And batch jobs do not typically respond to incoming messages. So they're meant to be created, execute a particular operation, and then when they're done, they exit. And batch jobs will not automatically scale. The main takeaway here is, unlike applications, batch jobs don't automatically scale. The number of instances we specify when the job is executed. So aside from not receiving inbound traffic, the mechanism by which they scale, batch jobs are similar to applications in pretty much every other way. So getting a little more in depth into Code Engine. So at a high level, Code Engine is a merging of all the various as a service containerized platforms merged into one. So whether your workload or your container is going to be running a function or a service function, whether it's there for a platform as a service type of application, like a web page or a 12-factor application, whether you're running a batch job that doesn't respond to HTTP requests, or you're responding to HTTP requests like eventing and infrastructure, it doesn't matter. As long as you containerize your workloads, Code Engine can run it for you. Code Engine, it runs it in the cloud and manages all the infrastructure behind the scenes for you. And it's not just a matter of managing the infrastructure. Code Engine also presents a simplified developer experience for you. Even though Code Engine is running Kubernetes, Knative, Istio, and other open source technologies under the hood, you don't need to know that they're actually there. You don't have to learn kube control to talk to Kubernetes and all the other stuff. Code Engine has simplified everything to the point where you only need to focus on giving the inputs into what you want to deploy. For example, when you give Code Engine your source code, if that's where you want to start from, or your container image, if that's where you want to start, it's completely up to you, and you have the flexibility to make that decision. Then you just need to indicate any runtime semantics that you want for your workloads. So do you want to scale based on load coming in or a certain amount of memory? For example, you'll just give Code Engine the raw numbers and runtime semantics you want, and Code Engine will figure out how to make the infrastructure match your desired needs. So you as a developer can basically just, give your applications and say, go run this for me. And you could get back to focusing on your coding, which is where you would preferably be spending most of your time as a developer anyway. You don't need to be wasting your time learning Kubernetes and managing clusters or anything else related to infrastructure in order to deploy your applications, so you can really just focus on your development work. Kind of to pull things all together, what you can actually do. Code Engine is a managed platform, so it's in the cloud. It will auto scale out your workloads for you, not just the application, the Kubernetes clusters that are running behind the scenes as well. Code Engine will scale that out for you, and you only pay when your applications are actually running. So if everything scales down to 0, you're not charged anything at all. It also supports scaling out based on resource usage, which is really great. So instead of the number of requests coming in, Code Engine will also scale out up or down your applications and workloads based on CPU and memory usage. It has built-in security for your applications automatically. So when you deploy to Code Engine, you'll see up in your browser window in the URL, we'll start with HTTPS. So you don't have to worry about setting up the SSL certificates, managing the load balancers, managing the runtime isolation between various workloads that you have running in the cluster. Code Engine does all of that for you. As I mentioned before, it also builds images for you. If you want to start with source code, you can integrate any IBM Cloud services. And not only can you communicate with them, you can tell Code Engine which ones you want to talk to, and Code Engine will actually inject the credentials and the coordinates of your instances into your application. So your application doesn't have to go figure out where your credentials are, what secrets they're stored in. They'll be available to you as environment variables within your application automatically. And lastly, unlike other platforms where there's going to be limits in terms of how long your things can run for, how much memory they can use, Code Engine doesn't have those limitations. So if you want to run something for 12 hours or you want to run high memory applications, you can go ahead and do that. We're not going to stop you. So unlike other platforms, you don't have artificial limits imposed on you. So I have some examples here. I have some cool stuff in the slides if you want to check it out. So for instance, in 5 commands, you can create a new Code Engine project, create an application from a container image. You can run, which we have in our workshop, you can run a load generator against your application. You can create a batch job, and you can run a batch job. So really quick and easy to get up and running. And again, if you want to get up and running and doing some of this stuff, you can do that by signing up for an IBM Cloud account. You'll create an IBM Cloud pay-as-you-go account. Code Engine does have a free light tier, so there's plenty of stuff that you'll be able to do. You won't get any charges for, and you can get, you know, a number of applications up and running and see how much, how many resources that you're allocating for each one. So I'm going to pass things over here. What we're going to be looking at today, and I've included the information for our use case, SiB Solutions. They're going to be telling you about their company, about their solutions, and giving you a really in-depth technical look into what it is that they do and how they're using IBM services and running everything, excuse me, on IBM Cloud Code Engine.
All right, thank you, Jenna. So I will then try to describe a little bit what we do, and I will try to tie that neatly into what you just described with Code Engine in the end. So let's see how that goes. As I said before, my name is Sverrir Valgeirsson. The name is Icelandic, and I don't expect anyone to actually be able to pronounce it except you come from there. As I said, I'm a computer nerd living in Sweden. I realized recently that I'm actually quite old, it's my background is that I started out on the Amiga computer writing assembly, and went to BSDs and then to Linux, learned how to make ASICs, and been working at companies like Sony and Ericsson here in Sweden, quite big ones, as well as many smaller companies, both technical jobs and in management. And yeah, so it's going to be fun to describe to you what we're doing. And if you'd change the slide, Jenna. So what problem do we solve? If you go one more. Have you ever ordered something online and gotten something else, or not gotten that what you expected, or got something broken? Well, yeah. I'm kind of assuming that most of you have. There's a poll there if you would like to fill in. I might be wrong on that. Maybe everything's perfect.
There's a poll question I have to answer.
Yeah, but I was more thinking I might be wrong on that. Nobody actually has these problems, but I certainly have, and many others I've heard about have had those problems, and we have set out to try to solve these. As you understand, if you get the wrong thing, somebody else probably also got the wrong thing, and there is a lot of things that can go wrong in the logistics area. It is a very complicated operation from when you press buy on something until you get it home. And there are extremely many steps on the way. So if you change slide. So we have that normally the flow of any item that we order. Now we're talking only then to consumer. That can be in any case. That can be to a delivery to a store, to anything basically. You have a manufacturing, you're transporting that, you have the warehouse, you transport again, and then it has to the last mile, and then it comes to consumer somehow. And we have focused on warehouses. There is a lot of things that can go wrong there, and let's see here. Yeah, and we tried to solve that problem. We have a background, many of us in the company, in the logistics industry as well. I named that I come from the IT industry, but our founders come from the logistics industry, and they've been seeing this for a while, that things were getting lost. We have seen huge things getting lost in warehouses. And also that there are problems proving who did what in the logistics flow. So our founders created this company to try to solve that problem. And what better way to solve a problem like that than with technology, of course. So that I thought was a very fun thing. So I joined, and we are now over 20 people. We are 7 developers. We are going to be more of us doing that. So we are increasing, and it's going quite well, I have to say. So the problem we're solving is the one that I described before, issues in the warehouse. And how do we do that? Next slide, please. So we have products to help people in the warehouse. We're very focused on that. We don't want to take away the decisions from the people that are working there. People make the best decision normally, but it is the case that when you're working in a warehouse, it can be a bit tiring. You can make mistakes, and it's nice to have an assistant that would tell you or nudge you if there is something going wrong. So we do that. We have products that assist and guide the operators. We use AR for that, light signals or sounds or whatever is needed. Here you have examples of product that we have installed at the customer called Hillebrand in Stockholm, where they are picking things into boxes, where we guide the operator where they should be picking, if the correct amount of things are in the boxes and the correct things, and which boxes are done, and so forth, so that they can have a better rate of delivery, so to say. They send the right things to the right places. Is always the person that will take the last decision. We will just inform them what we think of it. We use multiple data sources for this, of course, and this is a lot of AI and image manipulation involved that we real-time try to give this feedback. And then we also try to assist the warehouse management in the case of something going wrong. I was talking to a customer yesterday that had ended up with the customs in a country very, very far from us, having received a shipment where everything was turned upside down. And he was trying to explain that, no, they had definitely not packed everything upside down. So that must have happened on the way. But there's no way of proving that it left the warehouse not upside down, that they had actually turned the things the right way. And that's also a lot with damaged goods or anything similar. So you want to have images or video showing something. And that's another thing that we provide, is that we can very easily, in hindsight, search the video material. You can search for a certain shipment and find that in moments, and then be able to show how it looked when it left your warehouse. So these are the products that we make. And if you go to the next slide. And you might wonder how we do that when we get into the tech. So this is a lot of data. Each warehouse has a lot of cameras. Each station in the warehouse basically has at least one camera. It can be more. And those cameras are looking at what's happening in every station. And we also have all the other data that's coming from the warehouse about what should be happening from the ERP system. What is going to what customer at what time? What should be packed at what station right now? What is there to be expected? And we use the event streams for this to stream the data from the warehouses. And we stream them up to our code engine applications that are running there. That's called here a Smart Assistant in the picture. And there we form a picture of what is actually happening on the floor in the warehouse. And is this what should be happening, and what should happen next? And out of that, we also build the feedback for the operator, and we serve that back to the operator at the warehouse. And we do this for each warehouse. And you can imagine how much data this is, since a camera is doing somewhere around between 10 and 15 frames per second. Some do 30. And with a lot of cameras, that's a lot of data. Of course, we have computing power at the sites as well to reduce the amount of data that we have to transfer, but it's still quite a lot. And also that it's extremely hard to understand how much is going to happen. It depends on what warehouse is doing what at what time. And you can imagine the difference between a normal Saturday afternoon and Black Friday, for example. There's going to be a lot to do on Black Friday, always. So, yeah, and we use, or if you back one slide, sorry. Also, as you see, I put a lot of logos for other open source technologies here. We use MongoDB, we use Redis, we use HG, and of course the event streams. All of these things I know this is a code engine talk, but all of these services we also use in the IBM Cloud services that provide these services very conveniently. As Jenna talked about, that you easily can tie them into your code engine containers. So that's actually a very nice feature to have. Now, thanks. So if you go to the next one. So how do we think when we make these? So we have, this is maybe one of the more boring things that you're going to hear, and you heard it a lot. We like keeping things simple, and we think that that's the best way of going forward when designing something is complicated as this. And to do that, we use as much open source as we possibly can. The reason for that is, of course, that we want to be able to run things on our own. We don't like lock-ins. We like to be able to move if we have to. We don't see any reason to. We're very happy where we are, but we're not locked. Also, I can run everything on my own machine if I want to and try things out. And the skills translate very well from, I can find engineers that know a lot of the products that we use, and there's a lot of help to get in the open source communities. Another very good thing about open source when it comes to these things is, of course, that we decide ourselves when they go out of support. That's not something that we are dependent on somebody else on if we don't want to be. So, and we are in the warehouse business, and warehouses are not very keen on changing. So there are, of course, I assume that most people are very open to open source here, but there are a lot of reasons to try to keep it as much as possible in using these tools. We have tried using other tools that have been proprietary with open source-ish layers, and it never becomes exactly the same thing. There is always some problem in the simulation of the open source APIs. And we try to keep things extremely simple. Everything is a Docker. We don't use the feature that Jonah talked about that you can build from source code. We build everything ourselves and package it as a Docker and run it in Code Engine. And therefore, we can use any technology we like. And this is something that we hold very dearly, is that we try to use the right tool for the job and the person that's going to do the job as well. Different people simply like different things. So if somebody is tasked with a job, we use microservices, as it says here. They're normally not that big. The task is normally not huge. If the person prefers to use Go, well, go ahead. That's not a problem. We can use that. Of course, you're not completely free. You can't go with some language that is completely unsupported, but the big ones you can move quite freely. And since we containerize everything, it's pretty easy. And we use the best frameworks we can find for the problems we have. We use everything from Blazor, that's a .NET Core, C# framework that we use. We use it for UIs actually a lot. And of course we use TensorFlow, Flask, and we use Django, which is probably not the coolest one on the list, but it's extremely good as an ORM, and as its admin mode is second to none. So if you just need a database to get it automatically managed, it's there. So these are great technologies, and we choose what fits. So we don't try to reinvent the wheel, and try to focus rather on things that somebody has never done before. Also, we try to not optimize too much. There's ample power in the cloud for us, so we have no problem using Python, for example. It doesn't use the CPUs most efficiently, but it's good enough, and it keeps things very simple and easy to debug. And that's more important normally than the raw power we could get. Of course, some things we do change to Go or similar when we need to be able to use multiple threads, which Python is bad at. But yeah, we try to not optimize too early. And don't be too smart about things. How does this work, Jenna? Should I answer now questions that come, or should we take them later?
Yeah, we can answer them as they come in.
Yeah, we have absolutely considered keeping logistics info on the blockchain. We are more than, in that case, a should we say, one of the parts that would deliver to the blockchain. We are there would hopefully, and I know that there are many companies looking at this that are going to offer blockchains to be able to secure different parts of the logistics flow, and then we could put we can add onto the blockchain from our tools to show that this picture here or this photo here was taken at this time exactly, and that's signed. You can never change that, so you cannot fake it and stuff like that. Or we can guarantee that there were 14 yellow socks in this box at this time or something like that. So absolutely, we considered, and we're definitely keeping our eye on that technology. But we don't see a direct use for it in our use case as such, rather that we are a participant in a bigger blockchain effort in that case. I hope that answered your question. Anyway, so moving then to the next slide here, why IBM? And we have worked with different cloud vendors, and what we really like about working with IBM is that the services that we have, not only Code Engine, they're the actual services that we that are the open source services, so to say. They are not emulated in any way. So I'm getting an actual MongoDB, I'm getting actual Kafka. The message streams is just Kafka under the hood. I can use the actual Kafka commands, the Kafka Java files to communicate to it, and it works. The same with Code Engine, actually. It's extremely simple to set up and use. The logging is great, and it runs everything, but most of it is incredibly understandable. Anyone in my team can use it. A developer that wants to run something just goes into the web interface, clicks a bit, and then there is and deploys to the container. The testers can go in and change variables, change the load on the machine, change the environment variables and stuff like that. And it doesn't put any load on the rest of the team. Anyone can go in and do what they want. And then there's a good CLI that we can also automate everything that's in production. So the flexibility is great. And it's a very good thing to know that we can use kube control if we want to. I actually haven't needed to yet, but it's a very good thing to know that I can if I want. so to have the ability to actually go in and change things in the few events that would actually happen is a very, very big plus in my world. And it's extremely understandable. I really understand what I am buying. So how much, when I'm turning a dial, how much this is going to cost me, I can kind of understand it. It's not very sophisticated when it comes to that. So those are the main reasons we go with that. Great work, great UI, and extremely simple to use. And it's just one-stop shop. One-stop shop, right? That would be the term for that. We can run anything in it. Like Jenna showed in the beginning, it's like we can run functions, we can run applications, we can run batch jobs. It's the same thing. We don't need to teach people different systems to do that. We can concentrate on building our services. And well, we really like doing that. We don't want to be putting a lot of time into infrastructure. And then there is this little detail about security as well. It's a huge area to cover. And if we would be running all these services ourselves, if we would be running Mongo, if we would be running HD, Redis, and all that, we would have to keep up, of course, with their security bulletins and so forth, and keep them secure and keep our infrastructure secure. Now we don't have to do that. IBM has a little bit more engineers than we have, and they can keep track of that for us. So we can be very safe and assume that we can concentrate on keeping our stuff safe, and then IBM has our back there. And then there is this, it's a little thing that the code engine handles the certificates automatically. It's not hard to do it yourself, but it is a bother to handle it. And when the certificates run out and stuff like that, but they just don't here. It just works. So that's, so when we are developing our applications, we just build the container, we can debug that, we can single step through anything into the containers and work like we want. And when we're done with that, we can just deploy it, and all of a sudden there's HTTPS and there are certificates, and it works exactly like it did on my machine. So that's a very convenient way of working. So yeah, if you go to the next slide, I can say that we are a happy customer here, and we get all of this working, and all of this is running in the code engine that we do. So this was what I had. Thank you.
Thank you so much. So feel free to put any questions you have in the chat. We'll also share some information at the end in case you want to check it out and come back with any questions. We'll have a way for you to get in contact with myself and SiB Solutions as well with any questions. One thing I would like to do, since we have a little time, is let me just make this a little smaller. There we go. So one thing I would like to do is actually show you this in practice and show you just how quick it is to get up and running. So I'm just going to go to cloud.ibm.com. And I always use my personal account, non-work account. So, you know, I'm not using anything special. You know, I'm not using a work account. This is just my personal account, you know, so you can see what it looks like and what you have access to. So what I'm going to do is I'm just searching for Code Engine in the search bar at the top. This is the Code Engine console. So as you see here, you can go ahead and just get started. Goes over some of the features that we talked about. Deploy in seconds, it's truly serverless. Run your batch jobs, and it's all based on open source Kubernetes. And as I mentioned before, so for instance, I have, since I've started working with Code Engine and creating any content for it, have been using the always free tier. So It actually gives you a lot. You can get up to 100,000 vCPU seconds per month, 200,000 gigabyte seconds per month of memory, and up to 100,000 HTTP requests per month. So you can really do a lot without incurring any charges, without having to upgrade your account. So what I want to show you is just how easy it is to get started. So SiB Solutions works with containers, so everything they're deploying to Code Engine is a container image. So let me show you just how quick and easy it is to get started. So we have a sample container image here, so you don't necessarily have to come with your own. We have samples here for you to use. So I'm going to click Start Creating. Didn't have to do anything. I'm going to give it a name. I'm just going to call it My App. I have select my Code Engine project. So I have a Code Engine project already created. I'm using the London region. We have the image reference here, which I can change, but I'm going to just use what they give me. And I'm going to click Create. And that's it. So right now, what we're doing is we're deploying a container image from the Code Engine repository of a sample application to Code Engine. It was really a one-click deploy. All I had to do was, again, give it the container image, which a sample was already provided, and give it a name. And in the time that I've been explaining to you what it is that we just did, quick and easy, our application is deploying and it's already ready. So here is our sample application, and it was really that simple. It was really that simple. So you can give it your container image. You can update your container images easy from here. So if you see it on here, I could update this to another version. Or I could also add some source code and redeploy. What we're going to be showing some examples some more once we get into some Hacktoberfest events in a few weeks. So stay tuned for part 2. I'll show you hands-on how to deploy from container images and source code as well. So let's go ahead and use this sample Code Engine application to deploy from source code. So I'm going to click Start Creating. Again, I'm going to give it a name. I'll just call it My App from Source. Have my project selected. I have my source code, my GitHub repo here. So you might see here the crate is grayed out right now. So I'm going to click Specify Build Details. So here we have the code repo URL. This is a public repo. You can also use private repos. And then just indicating the branch. So we're going to be deploying from the main branch. You could also change it. Maybe you have different versions of your application, V1, V2, testing. And then, for instance, if your project is further nested, you can indicate the context directory. So I'm going to click Next. Didn't have to do anything. We're using a Docker file. So the strategy is Docker file by default here. And then at default, the registry server is already default. The registry access is automatic. I have a namespace here, and it created a image name for me. So I really didn't have to do anything. Just wanted to show you a few of the options you have. Yeah, so again, I gave it a name. I clicked a few things, and now I'm going to click Create. So as you can see here, the image build has been successfully created. So what it's going to do is it's going to wait for the image build. And what it's doing is it's using Code Engine's source to image feature to create a container image in IBM's container registry from our Git repository source code. And just refresh. Make sure my internet's going good. There we go. So we have, as you can see here, we have one instance. So this is having to do with that auto scale feature that I mentioned earlier. So when we deploy the number of instances of our application running, you can see here. So it will scale up or down depending on the amount of traffic. And also here in the runtime, you can designate, for instance, if you don't want to have to worry about cold start, as you can see here, you can increase your minimum number of instances to 1, so you don't ever have those issues with cold start. You can also select what you want to do for max. So you can limit how large, how big you want to scale out your application. So let's go back up here. And in the time it took for us to take a look at some of the runtime specifications we have here, our application is ready. And as you can see, it went from 1 to 0. So it auto scaled down while we were sitting here looking at it to 0 instances because the application wasn't receiving any traffic. So we can go ahead and take a look at the sample application here. So, and as you can see, because it scaled down to 0, right? So it truly scaled down to 0. So we just had a cold start to get this, an instance of our application up and running. As you can see here, we have our sample application up and running. And as I mentioned before, with the Code Engine auto scale feature, as soon as we're no longer using our application, it's no longer receiving requests, it will automatically auto scale down to 0. And what's really cool is what we're going to do in part 2 of this session. We're going to work with SiB Solutions, and we're going to create a really cool sample app for you and kind of show you in practice how to do some of the same work that they're doing with IBM Cloud Event Streams and Kafka. Move these slides down here. And so we'll be doing that in a few weeks. So I encourage you all to tune in. I'm going to share that in just a second. For instance, I'm just referencing the CLI commands again. So for instance, you can create a new project and create a new application from a container image into 2 commands here. So it's really simple and easy to use. It's really easy to use from the UI as well as the CLI. One of the things that I would like to share with you all, go here for a second. There we go. If you have any questions and you would like to connect with any of us offline, please feel free to do that. We are here for you as a resource. Posting that here. If you have a quick 2 seconds, literally 2 seconds, it's a 2-question survey. Feel free to give us any feedback, maybe some technologies you want to see, maybe some sample applications for Code Engine, maybe some integrations that you're interested in seeing. Maybe you're using, IBM Watson chatbots or, AI machine learning models or authentication or App Connect. Let us know what IBM products and services you'd like to see integrated into some sample applications and what you would like to see tutorials for. We'll be happy to get working on that for all of you. I posted the feedback survey link as well. If you're interested in joining us for our Hacktoberfest workshop, where we're going to expand on everything we just did today, we're going to do a little bit more in practice. Show you how to use event streams, show you how to use Kafka, show you how to deploy to IBM Cloud Code Engine. We're going to really show you in practice how to do these things with SiB Solutions. So it's going to be really fun and really cool. So you can register. I posted in the chat as well. It's actually at the same link you joined with today. just /2. So it'll be the part 2 for this talk here. If you have any other questions, please feel free to post in the chat. We have some time. In the slides as well, I have all of the resources for you, suggestions for certifications and things like that. And all of the information we went over today, including what SiB Solutions covered in the slides for you as well. So we can hang out and give it a few minutes for any questions. Unless there's anything that you, any of SiB Solutions or Doug on the IBM side, that you'd like to add?
I can add a little thing here about the you mentioned the light version or the light account, kind of, that there's a free account. I have played around with this a bit. I participated in a game jam and made the server side of a multiplayer game in Ruby and just threw it up on Cloud Engine, and a few hundred players, and I still didn't get a bill. So it's quite, it can handle quite a lot before it costs anything. So don't be afraid to click around.
Yeah, very cool. You're gonna have to share that game with us so we can all play too.
It's horrible, but it was a very short time, very, very short time game jam, and it really does torture the Cloud Engine, since it's is a rhythm game that tries to has to do requests, HTTP requests for every move all the time. So the updates are handled like that. So it's very evil towards Cloud Engine, and it stood up quite well. So that was a nice little test to do.
Clearly, our free tier is too good if you can do all that for free. Wow.
Yeah.
Well, you have to be able to play around, right?
We might not want to say that in front of Doug. Yeah, so part 2, where it's going to be interactive too. So if you're joining and you're not necessarily wanting to follow along, but you want to interact with us and with the application, we're going to make sure it's interactive so that you all can participate and have some fun with us too. Well, if we don't have any questions, as I mentioned before, please feel free to reach out to us on LinkedIn or, you know, YouTube, wherever it is that you like to be. Feel free to find us and reach out and ask any questions. And if not, we will see you back here on October 6th at the same time, same place. And we'll get hands-on and build some really cool stuff. So thank you all so much for coming. Thank you to our speakers. Thank you to SiB Solutions. And we will see you all next time. So have a great rest of your day and an even better weekend.
Thanks, everyone.